Bismillahirrahmanirrahim. Today we'll start with a new topic, which is composition. This is in continuation with our uh, previous lecture, which was about functions one. Composition is basically a way of uh, it is basically a way of uniting two functions and creating one function out of them. For example, if you have two functions, the first function is a set between f is a function between b, set b and c, and g is a function between a and b. So here is the g function and here is the f function. So what the g function does is it maps one element from the set a to another element of a set b, which is given by g of a. Now similarly, if you look at set the function f, it maps an element of set b and it maps it to a set of element C. Now we have a notation FOG. It looks like written like it is fog, but it is not actually fog, it is FOG, which is composition of F and G, the two functions. The composition means you compose them together, you attach them together. So when we say F of OG, that is basically you start off with a value X, which is an element of primarily the element of set A, and this result is g of x is an element of the set B, right? Because g maps the set A to B, right? Similarly, when you look at the element B, this element which is member of the set B, now this would be taken by this function and it would map it to an element of C. So FOG, this would be an element which would be a member of the set C, right? So this is how basically composition works. It maps. So essentially, you are taking an element from the set A and mapping it to the element of a set C, like here. See? So we could easily avoid the element between the set between B, and we can say that f of g maps the elements of set A to the elements of set C. So this is a basic idea behind composition. I hope this. Now, for example, here it is again. You are mapping A with Y and Y with J, right? So if you say that the FOG, the composition function, what would happen? It would be A would J. So the set element A from the set A would be directly mapped to the element J of the set C. So this is FOG. So it is easier to understand it with the mathematical example. For example, in this case, if f of x is x square and g of x is 2x plus 1. So if you take f of g of this FOG, so what happens is that f of g of x would be equal to 2x plus 1x square. Yani कि whatever you have here, you put it in this function, right? Put it here in x square, so you get this. And similarly, whatever you have here, you put x here, so you will get x square. So this is composition. So this would be, what would this be? This would be f o g, and what would this be? F, sorry, uh g of x. So this would be G O F. So this is the basic idea. So for example, you have a composition question. Let G be a function from the set A, B, C to itself such that G of A is equal to B and G of B is equal to C and G of C is equal to A. Let F be the function from the set A, B, C to the set 1, 2, 3. So such that this is the function definitions which are given f of A is equal to 3, f of B is equal to 2 and what is the composition of FOG, right? And what is the composition of G and F? So these two questions, so what we do is precise primarily we f of g f of fog of a is equal to f of g g of a is equal to g of a is equal to b and f of b is equal to 2, so fog of a is equal to 2. So similarly, but g of a is not defined. Why? Because the range of f is not the subset of the domain of g. So why is g of not defined? Because here whatever results a gives us are an input to the function f, but if we take 2 we cannot give it as an input to g, therefore g of f cannot be defined. So at times we cannot define the composition because of the difference in the range and domain of the different functions which are already which are of the given functions. Similarly here you can easily do it again, we already done it. So what would we do? F of g, we would put this here and this would be 3 into 2x plus 3 plus 2. So this would be, sorry, we had to put this one, the 3x 2x plus 3 which is 6 of x plus 11, sorry, this is this one, and 3 of x plus 2 is equal to 3x plus 2 and 2 into 3x plus 2 plus 3, right? So we can also build graphs of functions. Let f be a graph of function from the set a to b. The graph of the function f is the set of the ordered pairs a and b such that a of a member of a and f of a is equal to b. So f of n is equal to 2 of n. Now this is how we are building the graphs. You must have already built graphs in your high school, but let's do them again. So for n is equal to 0, it would be here, it would be 2. For n is equal to, so it would be, for n is equal to 0, it would be 1. For n is equal to 2, it would be 5. So this is 5, 1, 2, 3, 4, 5. For n is equal to 1, it would be 3. So this is the graph that is being built for this graph. For x square, you remember this used to be the graph. Sorry, I can't build it. So now we'll look at some important functions which we use again and again in our course. So the floor function. The floor function is an important function. This is denoted by this symbol. When you put this under some number, for example 3, this would be denoted that it is the floor. Use the mean here. It is the floor. So the floor function is the largest integer that is less than or equal to whatever is here. So if 3 is here, so what would be the largest that is less than or equal to 3? That is equal to 3, right? But if we had 3.5, right? So what would be the lowest integer? 3.5. Yeah.